Hi, I'm Paul Yoo, the other co-instructor for this class on applied regression using Stata. As Greg noted, the course has two parallel tracks, lectures that teach you the conceptual intuitions behind regression and statistics, and lab sessions with problem sets that teach you how to program in Stata and make sense of the output. I'll be responsible for the latter. The two tracks are more or less self-contained, so you should be able to follow along the lab sessions without the lectures without the lab sessions. Of course, you may want to do both by simply following the schedule laid out on the syllabus or doing both only as you need them, whichever works for you. If you're worried about programming because you haven't done it before, don't be. Most students prior to this course had very little exposure to programming, and they all did great. I also re-recorded the first video to make it even more accessible. I start with how to organize your files and load them into Stata. Unfortunately, that meant I had to record without an audience, so I didn't have anyone to stop me for questions. I ended up going into a lot of tedious details to be more thorough. In some places, so sorry about that. The week one video may be a little bit taxing to go through, but the next video should be better, much more dynamic, as they are the original recordings with students. We also point you to specific introductory resources at UCLA. There's a website that I think that they also have videos and like walkthroughs of like how to get started on Stata. Also like an introductory resource from Stata itself, Chuck Huber walking you through the interface and how to go about like just using Stata for someone who's never used it before. Those are all available either on the syllabus or on the do file, so you can look at them. If you still need something like a separate video by me, you can try and email me. And depending on the demand, I'll try and create another video that helps you sort of get started. People debate whether you should learn Stata or R. This debate seems to be everywhere, but I think you should learn both and also Python. And I did, and I'm still learning, and they're all good for different tasks with different levels of efficiency. They're all based in C, so learning one makes it easier to learn the other. And I think Stata would be the easier or the easiest of the three. In each lab session, I try to incrementally build Stata programming knowledge so you have a full understanding of the code that you are writing, as well as the output Stata is printing. The first 3 weeks are going to be designed to get you comfortable working with Stata and the class data set, which come from the ECHOLS-K, or the Early Childhood Longitudinal Study Kindergarten Cohort data from the National Center for Education Statistics. In week 4, you'll learn about nonlinear models, interactions, and essentially replicate a prior research study that used this very data set, the ECHOLS-K. Most students find these 4 weeks to be the most challenging. The learning curve is a little steep, but they all get through it. In the weeks that follow, we'll cover binary outcomes, spline models, visualizations, and fixed effects, and a few other things. Depending on how you like to learn, you can work through the problem sets first, then watch the lab videos as you need them, or you can start with the lab videos and then work through the problem set. Just know that the Stata do files for the lab generates the data files for the problem sets, so just be sure to run that do file before doing the problem set. The do files are also well documented, so you can choose to skip the videos and just read through the do files, whichever works for you. The lab session is going to have a lot of files, and so I made 2 short videos to help you get started on the lab materials. The videos are called like Getting Started. They're also written instructions, so you can skip the videos. In any case, the first video is going to walk you through how to download the public data set and create the class data set that we're going to use for this course. We can't distribute the data files themselves. The second one is going to walk you through where all the lab files are and what they are and what you need to do to make them work on your computer. Greg had the nice idea of making the course available to anyone that was interested because we recorded it, during the pandemic. And so I hope it's useful to someone out there. Last but not least, I want to make an important acknowledgement. The lab portion of the course that I'm leading has been developed and refined by each TA that came before me. I have tried to honor that tradition of further developing and refining it, but I'm simply just one person that has inherited the resources and I'm passing it on. Any and all errors in the current files are mine. I hope you enjoy or you like it. Feel free to give me or Greg an email. Tell us what's good, what's not so good, what would be helpful, and we'll try and maybe update the website somehow. Okay, thank you.